In the experimentation part, we are going to connect 4 batteries in series connection. This configuration is similar to that of an electric vehicle. Okay, so when you buy an electric vehicle, how we are connecting the batteries in series connection is similar to that of the experiment what we do in our solar lab. In the solar lab also, we have to connect these 4 batteries in which connection? Series connection. We have to verify the voltage, we have to verify the current, and we have to load for different ratings. That's what our experimentation part meant on the solar. Okay, so generally if you go for electric vehicle, this may have 2 rates of operating. Okay, generally if you connect 2 batteries in series, you will get a 24 volt system. But 24 volt system cannot drive a 3 kilowatt motor. You require little bit higher voltage rating. Okay, when you go for higher voltage rating, current magnitude will decrease, then the cross sectional area of the wire will decrease. Okay, so now in an electric vehicle battery, this cheap quality electric vehicles like normal brands, we use only lead acid battery. So if you open electric vehicle cabin, will be having like this structure only. So those batteries are also of lead acid batteries only. Okay, so now electric vehicle battery operating voltage is of system voltage is of 48 volts. 48 volts means, and how many batteries you require? 4 batteries, you have to connect them in series. So if you understand this configuration, then you can understand how a battery assembling is done in an electric vehicle. So this we are testing only with which kind of battery? Lead acid battery. So now of this, some electric vehicles are coming with basically lead acid battery, and some batteries are coming with lithium ion battery. So when you see this analysis, how many batteries we have? So this is operating with AC or DC? This stores electrical to chemical, and it will discharge from chemical to electrical. So I am having battery 1, I am having battery 2, battery 3 and battery 4. Every battery will have 2 ratings. What are those 2 ratings? One is voltage rating. So each battery, you can see here, when you connect an multimeter, each battery is of 12 volts, 12 volts, 12 volts. When you apply the KVL, the resultant voltage is how much? 12 into 4. 12 into 4, how much? 48. So this will construct a which system? 48 volt system. Okay, let's try to check each individual voltage. Now we can see these values here. Okay, so now I am connecting for the first battery. So it is indicating how much? 12.3 volts. Now it is a healthy system. Okay, next one, negative 2, positive 12 volts. Next battery. Okay, so again we are constructing 12 volts. Okay, so individual voltage I am measuring. Okay, so now it is also generating 12. 12 fours are 48 volts. Now I have to connect them in series. Sir, how to connect them in series? Okay, so the positive terminal is connected to negative terminal. The negative terminal is connected. You see here, the negative terminal is connected to positive terminal. Next, the negative terminal is connected to positive terminal. Next, negative terminal is connected to positive. If you do like this, how many are left out? One is positive, one is negative. That's how we constructed. Now, when you connect these 4 batteries in this sort of connection, then this construction is called solar battery array. This is called as an array in an, battery pack in an electric vehicle also. Electric vehicle also they will construct like this only. Okay, see here, what is the operating voltage? 12, 12, 12. So resultant voltage is how much? 48 volts. Coming to the rating of a battery. What is the rating of this battery? As is specified, it is 40 Ah. Okay, so what is the rating of this battery? 40 Ah, 40 Ah, 40 Ah. In a 40 Ah system, what is the resultant Ah of the system? So the resultant Ah of the system is equal to, okay, let's take each is of how much? 40 Ah. Okay, so I have a 40 Ah battery. Okay, I am running this battery for 10 hours. How many hours? 10 hours to give a backup. Then how much amount of current it can supply? 4 amperes. 4 tens are 40. So this battery will be charged for how much hours? 10 hours to charge or 10 hours to discharge. If you take a current of how much amperes? 4 amperes. Therefore, these 4 batteries are connected in series or parallel? Series connection. Therefore, how much amount of current will flow? 4 amperes current only will flow. Why? Because in a series, what is constant? Current is constant. Therefore, current is equal to how many amperes? 4 amperes. Current is how many amperes? 4 amperes. And the capacity of the battery is how much? Into 10. Therefore, what is the capacity of the battery? 40 Ah. Since current is constant and hours to charge or discharge is also constant, 4 into 10, how much? 40 Ah is the total array voltage is nothing but 40 Ah is the total system Ah capacity. What is the total Ah supplied by this system? Only 40 Ah. Okay, so this can supply only maximum how much? 40 Ah. So now it is supplying 40 Ah of capacity. Okay, so now let's try to do the calculation part. Okay, so now what is the maximum current? As per our analysis we have taken 4 amperes. Okay, so 4 into, I want to decide the ratings of the fuse. 4 into, so I mean 1.25, where 1 represents 100 percentage, 0.25 represents 25 percentage. So we are multiplying 4 with 125 percentage. When you square it, how much it is? 4 into 1.25. 4 into 1.25. Approximately you are getting 5 amperes. That's why we kept an fuse here. You see this fuse, single strand we used. Okay, so single strand fuse, maximum current it can withstand how much? 5 amperes. If you load our equipment more than 5 amperes, then automatically this fuse will blow off. These fuses are called as Kit Kat fuses. Okay, so Kit Kat means this is how to open and how we are closing. This is why it's called a Kit Kat. Okay, so now we are going to close the fuse. So now, so resultantly how many terminals you are going to have? One is positive, one is negative, and through this connecting wires we have been connected the positive and negative. So resultant positive is this one, resultant negative is this one, and in order to enable better protection, we kept an miniature circuit breaker, little bit higher current rated. Okay, so this is a 5 amperes. This we designed with 10 amperes range. 10 amperes range, and we are connected the positive and negative, and resultant positive and resultant negative we are getting here. Resultant positive and resultant negative. Okay, so now when you connect it, let's try to check the voltage and current, and we'll do the experimentation part. Okay, so now let's try to measure the voltage. So now when you check the voltage, what you have to do? So already these are in connected to the load, just you turn on. Okay, so the resultant voltage you are going to get like this. Okay, so this is positive terminal and negative terminal. So as per the theory, how much it is? 12 fours are 48. So how much voltage you are getting?
51 volts.
51 volts. Or why you are getting higher? So we have it not loaded. That's why you are getting higher. When you load it minimum 1 ampere, then automatically the voltage will drop to 48 volts. Already you know that when you don't no load, under no load condition you will get higher voltage. When you load it, the voltage will decrease. By that you are going to calculate regulation. Okay, V no load minus full load divided by full load, it's called voltage regulation. Okay, so now we have been connected. So directly you can see here we have been connected to 60. Okay, so how much it is indicating? 25, 26, 26 into 2. 26 into 2 how much? 52 volts. Okay, resultant this series connection is generating how much voltage? 52 volts. And already you can see this circuit diagram. You can see by the circuit diagram. So here let's assume that we are connecting one more battery here. Here you have one more battery. The resultant is joined like this. Now we have 4 batteries we have been connected. So we are connecting this voltmeter. What are the output terminals of this battery? Positive and negative. Current is entering to the ammeter as positive. Current is leaving the ammeter as negative, and entering to the rheostat as positive and leaving the rheostat as negative. Okay. So now the output of the system. Okay, so this is nothing but the positive terminal of the system. We are going to connect the voltmeter in parallel, and ammeter and rheostat we are connecting which connection? Series connection. Why? Because negative terminal is connected to positive terminal. I can say the current in this branch is constant. Okay, so now we want to give this connection. Okay, so you see here to give this connections. So these are the resultant positive and negative. So the resultant positive and negative directly we connected in parallel. Now this ammeter and this rheostat we have to connect in parallel. And one end of the positive we are connected to the one end of the ammeter. Okay. So which end we are connecting to the ammeter? Ammeter positive terminal we are connecting. Okay. From negative terminal of the ammeter. Okay. So this is nothing but the negative terminal of the ammeter we are connected to the rheostat input. Okay, this will act as generally rheostat input, and the variable terminal. So this is nothing but the variable terminal we are going to connect to the output. Okay, so now you see here, ammeter, from ammeter negative you are connected to the rheostat positive. Output, I mean variable terminal of the rheostat, you are connected to the negative of the system. That's how this ammeter and this rheostat are connected in series. Okay, you can see this directly. Positive is going to the ammeter and negative of the ammeter is going to the input of the rheostat, and output of the rheostat is connected to the negative. That's how it is forming a closed loop. Now let us try to take some set of readings to understand this calculation. So what is the voltage we are getting? First write down. Serial number 1, voltage is 26 into 2. And write down the current here. 0.6 into 2. 0.6 into 2 is how much? 1 point already we loaded. Default how much load is there? 1.2 amperes load. Okay. We will go maximum only to 5 amperes. Okay. So now I am gradually. So now what is the position of the rheostat? Maximum position. That's why the current is minimum. So from maximum I am coming to minimum. Okay. So now I am slowly varying here. So write down the current. Current is 0.75 into 2. Serial number 2. Current is 0.75 into 2 and the voltage is 26 into 2. 26 into 2. Next reading. 0.8 into 2. I mean 1.6 amperes approximately. So this is 26 into 2. 26 into 2 is how much? 52. Still it is under which condition? No load condition. It is not much loaded. Okay. Now gradually let's try to write down the current. 0.9 into 2. 0.9 into 2. And the voltage still it is indicating 25 into 2. 25 into 2. Now the current is 1 into 2. So we are taking the current as reference, not voltage. Current as reference is 1 into 2. And voltage is 25 into 2. Next current. One point five into 2 and voltage is 25 into 2. Next 1.2 into 2. 1.2 into 2. Voltage is 25 into 2. Next. Direct line going for 1.25. 1.25 into 2. 25 into 2. So I am not going much deep because it is fully loaded. So maximum 3 amps we are applying. And make it fast. So 1.5 into 2. 1.5 into 2 and voltage is 25 into 2. Okay. So it's already get it fully loaded. So make it fast. So 2 amperes. 2 into 2 and 25 into 2. Okay. So here we should not take more readings than already 2 into 2 is how much here? 4 amperes. If you go beyond 5, what will happen? First this will trip out and this will trip out. Okay? And this resistor will try to act, and this rheostat will try to act as a dead short circuit. There is a chance of damage. Okay? So that is how to connect 4 batteries in series connection, and connecting these 4 batteries in series connection is called as an array. In this connection, what is increased? Voltage or current? Current is constant. What is increased? Voltage is increased. Okay, that's why you are getting still. Now, how much amount of load is there? Minimum load. What is increased? Voltage is fixed. Voltage is doubled how many times? 4 times. If you use 50 battery, 12 into 5, 60 volts you will get. So, for better voltage, if we increase the voltage level, what is the advantage? V into I equal to P. If you increase the voltage level, current magnitude will decrease. If current magnitude decreases, then you can use thin size wires. If you use only one battery and load is how much? Around 2000 watts or 200 watts, what will happen? current value will increase. If current value is increased, then you should use the double cross-sectional area. So around 4 square mm, like that you have to go with higher. If you increase the size of the conductor, the cost increases again, and loss also will increase the DC system. So this is how to connect the batteries in series connection. How to construct an array. The same array will be there in your electric vehicle. So when you become an electric vehicle manufacturer, or when you become electric vehicle service technician, then when you open the cabinet, then you can see these batteries will be connected in series. So this is about how to connect the solar panels, how to connect the batteries and solar panels of same. We had already done the experiment how to connect the solar panel. Their solar panel is also generating what? DC. Their battery is also generating what? DC. The concept becomes same. But there we have power rating, here you have AH rating. Okay, there we calculate power density, here we calculate energy density. Okay, so this is all about how to connect the batteries in parallel connection to construct an electric vehicle array. Photo would be